classic point and click. In the last episode, we fixed our scripts to work with the new Unity input system. This time, I will make things move. Hold your seat. I first need to create an abstract character class. It will let me define what each character can do. I will create a folder to maintain the project well organized. Let's edit the script. We will first define it abstractly for better encapsulation, simplification, and scalability. Each character has a vector 3 of its current position. Another vector 3 will represent the character's destination position. The character's rigid body component. The character's animator. Add an abstract method to move a character to a destination position using a vector 3 data. Add an abstract method to update the character's position. Add an abstract method to update the character's direction. That's it for now. Let's make simple use of our character class. A simple use could be our player, which is a character. Create a player script that inherits character. Clean as a full moon. Inherit the character class. Using advanced IDE, I am auto-generating the method's overrides. In order to make my player move, I need a float representation of the player's speed. Serialize field allows me to easily edit the float's value from my inspect window while keeping it private. I add another float to control my player's turn speed. A bool that will represent if the player got to its destination. Add a vector 3 that will get the position from our input system. Get the rigid body component. Get the animator controller from the game object's children. I set the current position to the player's transform position. I reset the destination position when the player's initialized to the scene. Let's add an update method. We can feed the input position vector 3 using our click input instance method and get the input position. Let's quickly debug the behavior. Everything works as expected. To use my move character to position method, I first validate that the transform position is not set to the player input position. Then I can use my method by sending my new player input position. Right afterward, I will update my player direction and my player position. Let's describe the override move character to position method. First, I set the destination position to be a new vector 3. I use the required parameter information destination and keep our Y position to our current transform position. Next, I check if the destination bool is true and reset the trigger. Let's jump to describe the override update character position method. I set vector 3 as my direction by using the relation between the destination and player input positions. I reset my direction to use its transform position Y-axis. I use vector 3's magnitude to get the length of my vector 3, which is the distance. I check if my player's distance is close to its destination. If so, stop, resets forces, and play idle animation. Otherwise, we normalize the direction's vector 3, meaning it retains and keeps its direction. Then we can easily feed a movement vector 3 with our movement direction by my player's speed by the delta time, which is the interval in seconds from the last frame to the current one. Next, we will use our rigid body components method to move position and increase it by the player's movement. I must keep track of my player's current position after it changes. And play my movement animation. Let's check our player's script. The player moves to the required destination, just as expected. Nice. While debugging, I notice that my player returns to 0 whenever I tap a void location. To fix this behavior, I simply make sure my player input position is not set to 0. Everything plays as it should. Good job! Later in this video, we will edit our player model to visualize our player's direction. For now, I will keep describing my override method to update our game object direction accordingly. I found a way to get the direction, and later on, I can reuse it to make another layer of polymorphism in the future code. I first validate that my player direction is not 0. I can make use of quaternion. Quaternion is simply a way to represent spatial rotation in 3D spaces. It is optional to understand the mathematics behind quaternions. Unity simplified this for us and created ready-to-use methods which are more intuitive. For example, we can transform any forward vector 3 to our look rotation using quaternion look rotation. My player direction will fit in. Next, I can quickly reset the player's transform rotation to our destination rotation quaternion. One more aesthetic way is to use slurp, which creates smooth linear interpolation in vector 3. But in our case, the slurp stands for spherical, and spatial rotation is spherical. All I need is from aka player direction to aka b destination direction, and time aka t time factor. In this case, I can use my player turn speed float to better future tweak the interpolation. For now, let's pass our direction. When approaching the first abstract class declaration of an abstract script, allow yourself to code freely and smoothly. The abstract class keeps your infrastructure tight and has few possibilities to mess with. In the future, I will refactor and seal every script to meet conventions and follow the OP pillars better. The following part is a bonus part of how to animate better our minimalistic characters and make them more specific. This part shows a different side of Unity and gives simple technical and artistic tips for beginner game designers and developers. You should go with your creativity and share your players and characters with me. First, I run a play mode and try to position my player's orb in front of its forward position. Then I can copy the transform information while in play mode, leave the play mode, and paste the data. I created a bunny tail by mistake, so I changed the minus to a plus. The idea of parenting in the hierarchy allows both the player model and the player's orb to follow the axis. Let's tweak our player movement. Using our player script's serialized fields, we can easily modify the speed and the turn speed. Speed in game design can be a challenging factor or an element of freedom. It also creates a feel and describes your characters. Fast as lightning, slow as a rock, or something in between. Speed is undoubtedly a characteristic feature. Take your time to find the most suitable values. Here is a fast forward of adding player hands using two simple spheres carrying our player material. First, we create and position it, and then we can duplicate and turn the values negative to quickly mirror its transformed position. That will do for now. Let's add some cute eyes. Same as for the hands, but we can add some edge with scale and rotation. Also, we should use a different material or color. Make some wee tweaks to set things straight. Shift them peepers, give 'em some oomph. Make 'em pop. Mind ya, don't be neglecting them hands. Reposition 'em just so, making it seem like they be holding some hidden magic. Oh, and the magical orb, the mystical orb. Give it a shimmer and shine, me dear game designer. That'll be enough for now, me fine companion. In our next chapter, we'll delve into the realm of basic animation techniques. Get ready for a grand adventure. Before you embark upon the next thrilling episode, always bear in mind to show your appreciation by liking and subscribing to me channel. Your support be the wind beneath me wings, allowing me to create and share more wondrous content with ye. Many thanks, me hearties. May fortune smile upon ye, and good luck be with ye on your journey.